unit cells. These unit cells were arranged in a hexagonal pattern with the base plates at the back end, forming the reactor core. The bundles of fuel elements were centrally supported with a single tie rod, and each fuel element no longer flowed to a single hole in the base plate.
In 2C, the thought was, let's not dump each flow passage into a base plate hole. We get a better structure from scaling laws if the 0.29-inch hex fuel elements dump, 7 fuel elements dump into one hole.
Each unit cell was supported by a tie tube. The larger tie tubes contained control rods, and the smaller ones were ordinary tie tubes.
The assembled reactor core traveled by truck across California to Site 401 in February 1964. In the disassembly building, the core was mated to the diffuser and exhaust nozzle, making it a complete nuclear ramjet engine. Tory 2C was assembled and mounted on the rail car, ready to travel to the test stand. The 2C was ready to prove it had the power to fly the PLUTO missile. It set out on the Jackass Flats rail line to the test stand. This trip had been repeated many times with the 2A and 2C over the previous 4 years, with only one incident marring its record for safety.
We had one untoward accident with a test vehicle. It had no reactor in it at the time. It slid a little too fast into the face of the bunker and did some damage. The damage wasn't too extensive. So the standard joke around wasn't too funny to me and some of my colleagues because we were here when it happened, but the standard comment around was this railroad had the highest accident per passenger mile in the world.
On May 20, 1964, the Tory 2C rolled to the test stand. It was huge, weighing in at 14,410 pounds. It was the end result of the work of 450 individuals and over 250,000 man-hours.
Very good air temperature. All right, we're ready to proceed.
Here at the test site, at times we'd have as many as 100 persons here, and I think there were 200 or 300 at Livermore working on the project for several years.
The amount of money spent by the Atomic Energy Commission and the Department of Defense by the end of fiscal year 1964 was $320 million.
Air Force, start sampler.
The wind direction is checked one final time. It's blowing away from the population centers of the Southwest. With conditions in their favor, the technicians start the full power test. An expanded tank farm provides for a longer test run, 5 minutes at full power. As the reactor core approaches 500 megawatts, the base plates glow at over 2,400 degrees Fahrenheit, less than 200 degrees below their auto-ignition point.
2360 and low. Holding on the plateau.
The Tory 2C test program worked excellently. We ran Tory 2C after the cold blowdown and a few operations at very low power. We ran our design point power run for 5 minutes, achieved the power, the temperature, the performance that we had predicted. It was a success from any point of view.
Following nicely, Chip. How you doing, Roy? Just fine, 1800. All right, you can start it again, Stan. Coming down. All right, Stan, you can bring on down a ways now. This is Reynolds. The run is a complete success. The reactor is ready for flight.
After the 5-minute full power test, the Tory 2C reactor returns to the disassembly building for inspection. Light projected through the fuel elements shows no sign of cracks or plugs in the reactor core.
Following the tests, the reactors were disassembled for recovery of the uranium, and we found no evidence of base plate coating loss.
Precise measurement of the temperature of the exhaust of the reactor is complicated by extremes in temperature and air pressure.
One of the ideas for measuring the temperature profile in the exhaust stream was to put a thermocouple rake across the stream. This had aerodynamic problems, flutter problems on the rake, and generally didn't give us satisfying data. With this kind of stimulus, Dick Werner in particular and a physics colleague said, hey, we can relate the temperature closely to the color in a color picture of the back end.
An object that is generating enough heat is also generating a visible spectrum of light. This light can be described as the object's color temperature and can be captured on film. To relate color temperature of photographs to the actual temperature of the base plates, the density of each layer of emulsion in the film was measured. The density of small areas of the film taken during the test was compared with that of film that had been exposed to an equal amount of radiation, but no light. The difference between these densities allowed the engineers to calculate the color temperature of the base plates. After overcoming all of the challenges in designing a nuclear propulsion system for a ramjet missile and proving the capabilities of that system, there was one more challenge.
Once you had the engine, how do you match it to the airframe, and how do you, especially how do you flight test it? You have a nuclear reactor with wings the size and mass of a locomotive. It's not something you can obviously test easily. They had various ideas of putting it on a tether, for example, and having it out of the Nevada test site. But as one of the engineers said, there was no way to guarantee that it wouldn't get loose from the tether and make a low-level pass through Las Vegas or even Los Angeles.
After the successful tests of the Tory 2C, it was announced that the program would not be continued into the next fiscal year. Program director Ted Merkel was asked to run tests at specific design points before the July 1st cutoff date.
To Ted's credit, I think, was the decision to stonewall that. We had this successful program. If for some reason we were going to do another test and we had a problem, there was no way that we would have enough time and money to fix it and redeem ourselves before the 1st of July. So we didn't do any more testing.
There would be no flight test program. There would be no finishing off of the project to a weapon delivery system. In other words, we were finished.
There were lots of pieces of information going around as to why the ballistic missile program by that time was very, very successful, and also the expense of the next step of a test of a device like this would be huge, so those must have contributed somewhat to the decision.
Project PLUTO was not the only missile project aimed at the Soviet threat. Development of ICBMs produced a missile capable of carrying a warhead over 2,500 miles in 1959.
It was primarily the fact that the ICBM could do the job easier and cheaper. and quicker. And there was also finally concern with the test ban. By 1963,